FastMCP 3 implements hierarchical server composition through mounting, enabling modular organization of version components while maintaining isolation between API surfaces. The framework's transform pipeline applies version filtering at the parent level, allowing child servers to expose multiple implementations of the same tool under versioned identifiers, while the parent selectively surfaces specific versions to clients. We're about to examine how a child server registers two versions of a process tool, while the parent server mounts this child under a namespace and applies a version filter to expose only the one implementation to clients. The code demonstrates how version constraints propagate through the server hierarchy while preserving component identity through namespacing. From FastMCP, import FastMCP. From FastMCP server transforms, import VersionFilter. Hash child server with version components. Child equals FastMCP child. Child tool version. Def process data, SDR. Return data upper. At child, tool version equals to 0. Def process data, SDR mode, SDR equals default SDR. Return data upper if mode equals default, else data lower. Hash parent server mounts child and applies version filter. Parent equals FastMCP parent. Parent mount child, namespace equals child. Parent add transform version filter version LT equals to 0. Hash client see only child process v10. This code demonstrates server composition and version filtering in FastMCP 3. The pattern shows how to create modular servers with version components and control API surface exposure through parent-child relationships. The child server defines two versions of a process tool, with v20 adding an optional mode parameter. The parent server mounts the child under the child namespace and applies a version filter that only exposes components with versions less than 2. The key mechanism here is the combination of mount and version filter. Mounting integrates the child server's components into the parent's namespace while maintaining isolation, while the version filter transforms the component list before it reaches clients. This approach enables API versioning without requiring separate deployments, as different version filters can create distinct API surfaces from the same underlying components. This pattern is particularly useful for maintaining backward compatibility during API evolution. By versioning components and using filters, you can support both legacy and new clients from a single codebase. The trade-off is increased complexity in component management, as you must maintain multiple implementations. The namespace prefixing prevents naming conflicts when composing servers, while version filtering provides fine-grained control over which implementations are exposed to different client groups. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core server functionality for the Model Context Protocol MCP framework. This class serves as the foundation for creating MCP-compliant servers that can expose tools, resources, and other components to clients. From FastMCP server transforms, import VersionFilter. Imports the VersionFilter transform class from the FastMCP server transforms module, enabling version-based filtering of components in the FastMCP server. Child equals FastMCP child. Creates a FastMCP server instance labeled child for identification in MCP protocol handshakes. The string parameter serves solely as a server identifier and doesn't configure functional behavior or operational modes. This instance can later be mounted into other servers or used standalone, but this line only shows its creation with the given label. Child tool version. Decorates the child class method as a tool with version 1 in the FastMCP framework. This makes the method available as a versioned component that can be discovered and invoked through the MCP protocol. The version parameter specifies this particular implementation of the tool, allowing multiple versions to coexist under the same tool name.
Def process data, SDR.
Defines a function named process that accepts a string parameter data and returns a string. The type hints indicate the input must be a string and the output will be a string.
Return data upper.
Returns the uppercase version of the string stored in the variable data. The upper method converts all alphabetic characters in the string to uppercase, leaving non-alphabetic characters unchanged.
At child, tool version equals to 0.
Decorates the child tool with version metadata, explicitly setting its version to 2 for MCP protocol exposure. This version identifier will be visible to clients querying available tools and used for version filtering when multiple implementations exist.
Def process data, SDR mode. SDR equals default SDR.
Defines a function named process that accepts a required string parameter data and an optional string parameter, mode, with a default value of default. The function is declared to return a string value.
Return data upper if mode equals default, else data lower.
Returns the input data in uppercase if the mode is default, otherwise returns it in lowercase. This conditional expression evaluates the mode variable and applies the corresponding string transformation to the data.
Parent equals FastMCP parent.
Creates a FastMCP server instance named parent that will be identifiable as parent in MCP protocol handshakes. The string parameter serves solely as a server identifier for client recognition during protocol interactions.
Parent mount child, namespace equals child.
Mounts the child server into the parent server with a namespace prefix of child. This makes all components from the child server available through the parent, with their names prefixed to prevent naming conflicts. For example, a tool named process in the child would become child process in the parent.
Parent, add transform version filter version LT equals to 0.
Adds a version filter transform to the parent server that filters out components with version 2 or higher, only exposing components with versions less than 2 to clients. The transform operates at the server level, affecting all components from all providers after any provider-level transforms have been applied. FastMCP 3's hierarchical composition shines here through 2 core mechanisms: mounting for modular organization and version filtering for controlled exposure. The child server demonstrates versioned component design by registering 2 implementations of the same process: tool v10 with basic functionality and v20 with extended parameters. When the parent server mounts this child under the child namespace, it gains access to both versions, but prefixes their names to prevent conflicts. The critical insight comes from applying the version filter transform at the parent level, which selectively exposes only components with versions less than 2. This combination lets you maintain multiple implementations in a single codebase while precisely controlling which versions clients can access. The pattern enables backward compatibility without deployment fragmentation, though it does require maintaining parallel implementations. Namespacing ensures clean composition when building complex server hierarchies, while version filtering provides the fine-grained control needed for API evolution.
The namespace locks the tool in place, yet the version slips through like a shadow in the code.